Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4 that consists of Muhammad Khairul Hakim bin Wahmad, Fatimatul Akmal binti Maksaud, Nur Alisa binti Anwar, and me, Nur Almirah Najwa binti Mahdir. There are several types of reactor that consist of batch reactor (BR) or steel tank reactor. Secondly, continuous reactor, which is tubular reactor or plug flow reactor. Thirdly is fixed bed reactor, which is packed bed reactor. Next is continuous stir tank reactor. Last but not least, slurry reactor.
Assalamualaikum, I am Nur Alisa binti Anwar. Today, I will explain about a batch reactor. Firstly, a batch reactor is defined as a reactor in which the reactants are added to the reactor before the reaction begins. In this slide, you can see in the left how the reactor works. When using batch reactors, reactants are first placed inside the reactor and then allowed to react over time, and then the products form inside the reactor. Following reaction, the reactor is cleaned to prepare for another batch of reactants to be added. After that, the products and unreacted reactants and then removed, and the process is repeated. In this situation, batch reactors contain ports for injecting reactants and removing products, and can be outfitted with a heat exchanger or a steering system. Last but not least, this reactor consists of a variety of applications, like the reactors are commonly used in liquid phase reactions that require a long reaction period, such as the fermentation of beverage product. Second, the reactors also used in the pharmaceutical industry, in which it requires consistent and high-quality results. Lastly, it also highly used in wastewater treatment, which are effective in reducing biological oxygen demand of effluent untreated water.
Assalamualaikum, my name is Fatimatul Akmal. So I will explain about tubular reactor, or known as plug flow reactor. Consists cylindrical pipe with opening on each end for reactant and product flow through. This reactor usually operate at steady state, and the reactant are continuously consumed as they flow down the length of the reactor. The video shows the operation of a plug flow reactor, which the reactant are continuously fed into the reactor from the left. As the plug flow down the reactor, the reaction takes place, resulting in an axial concentration gradient. Product and unreacted reactant flow out of the reactor continuously. Plug flow reactor might be configured as one long tube or shorter tube, which range in diameter based on construction cost, pumping cost, the desired residence time, and heat transfer needed. Usually, short diameter tubes are used with high reaction rate, and vice versa. Did you know this reactor have many applications in either gas or liquid phase system, such as gasoline production, oil cracking, synthesis of ammonia from its element, the oxidation of sulfur dioxide to sulfur trioxide, and lastly, tubular reactor can be used as bioreactors for the production of algae, which is then compressed and dried, after that used as feed for biodiesel reactor.
In this slide, I'm going to talk about a packed bed reactors, which also known as fixed bed reactor. The reactors are heterogeneous reaction systems that consist of a chamber, such as a tube or channel, which contain immobile stacked catalyst particles or pellets within a vertical vessel. The animation in the left show off a basic operation of a backbed reactor. The reactants, which is a green color, enter the reactor on the top and then the reactants flow through it. Upon entering the reactants flow through the backbed of catalyst. By contacting with the catalyst pellets, the reactants react to form product, which is the blue color, which then exit the reactor on the bottom. Next, backbed reactors are employed in a wide range of applications, such as first, the reactors are used in small-scale commercial reactions. Second, the reactor also used in chemical processing applications like adsorption, distillation, stripping, separation process, and catalytic reactions. Lastly, a backbed reactor is a type of reactor that used in petroleum refining industry, which uses a natural gas as a feedstock.
And now I will explain more details how continuous stir tank reactors work. Did you know continuous stir tank reactors are the most basic of the continuous reactors that used in chemical processes? CSTRs are open systems where the material is free to enter or exit the system to operate on a steady state basis where the conditions in the reactor do not change with time. Products are continuously removed, while reactants are continuously introduced into the reactor. CSTRs are very well mixed. The contents have comparatively uniform properties such as temperature, density, and so on. The conditions in the reactor's exit stream are the same as those inside the tank. There are several applications of the reactor. Firstly, fermentals. Fermentals are another application of CSTRs that involve the use of a biological catalyst to generate products. In a fermenter, microbes catalyze a reaction that breaks down much larger molecules into smaller molecules such as ethanol, methanol, or other hydrocarbons. Secondly, CSTRs are also used in the pharmaceutical industry as a loop reactor. Next, continuous stir tank reactors are most commonly used in industrial processing, primarily in homogeneous liquid phase flow reactions where constant agitation is required. Lastly, continuous stir tank reactors are often used in biological processes for high-density animal cell culture in research or production.
Assalamualaikum and selamat sejahtera. My name is Muhammad Rahman and today I will be explaining about slurry reactor. Slurry reactor is a multi-phase reactor system that can be carried out in solid, liquid, and gaseous phases. The slurry reactor can be carried out in two-phase or three-phase catalytic reaction that I will be explaining later. The slurry reactor can consist of a catalyst which is usually solid suspended in a liquid through which a gas is bubbled. However, for the reaction of gaseous reactant with catalyst is usually carried out in a fixed reactor. The reactor can be operated in batch, semi-batch, and continuous mode. How does slurry reactor work? This video shows the basic operation of a slurry reactor. Inside the reactor are catalyst pellets suspended in liquid. Gas reactant is bubbled up to the reactor. The gas is absorbed into the liquid from the bubble surface. The absorbed gas then diffuses through the liquid to the catalyst surface, at which point it diffuses into the catalyst pellet and the reaction takes place. In two-phase reactor, fluid phase is usually liquid reactant in contact with the solid catalyst, while in three-phase reactor, gas and liquid reactants are brought into contact with a solid catalyst particle. In three-phase slurry reactor, the gaseous reactant and the solid catalyst are dispersed in continuous liquid phase by a mechanical agitation using stirrer. The efficient stirring ensures nearly uniform composition throughout the reactor. Slurry reactant is used for the application of hydrogenation, oxidation, hydroformation, halogenation, ethylation, and fermentation, as well as catalytic cracking process. Slurry reactor is also used in wastewater treatment, stack gas crumbling with lime and magnesia, and also olefin polymerization using catalyst suspension. So slurry reactor is very useful, especially because it can react in 2 phases or 3 phases, which is available for gas, liquid, and also solid. That is why it is a very important technology for industrial.